Everyone. Aaron Smith and Nancy Bakeman with the Energy and Environmental Building Alliance, and welcome to our EBA webinar podcast series. We're joined today by Joseph Hillenmeyer with April Air, and he's going to be speaking on whole home ventilation for today's builds. I also want to do a couple housekeeping things. If you're not aware, we have a IECC 2021, Energy Star 3.2, Zero Energy Ready Home 2.0, and Energy Star Next Gen training program series coming up. Our next training will be here in Minneapolis, where Nancy and I are, on the April 30th and May 1st, and that is sponsored by Xcel Energy. And then our second training after that will be May 8th and 9th at Construction Instruction in Denver, Colorado. And we are pleased to have Gord Cook back speaking with us. And then for everyone on the line, we have the EBA Summit coming up October 2nd and 3rd in Salt Lake City, Utah. So we're really looking forward to that. So that's a couple housekeeping items. Nancy, anything that you want to add on the housekeeping side?
No, that's it. I'm
Great.
going to put those links in the chat for those
Okay.
events.
So watch for that. I know we've got several people here from Minnesota on the call, which is great, and several from Colorado as well. Joseph, how are you this fine spring day in the Midwest?
I'm great, and it is a nice day for April in the Midwest, isn't it? So
It is, I'm sorry, I'm going to do dad humor here for you, Joseph, but there's no better time to have April Air on the call in April.
In fact, I believe the story is that I should probably know it better, but the wife of one of the founders, when they were naming the humidifier, they talked about the freshness of the air, and she said it's like April air, which goes to show our Midwest Wisconsin roots, right? Because there's parts of the country where you might not say that, but here, April, it's like, we've finally gotten rid of the winter climate, the cold. We're getting into livable conditions again. So
yeah, well, we finally can open our windows and doors again, right?
Right. But today we're going to talk about why you shouldn't do that.
That's exactly right. That's exactly right. And yeah, well, Joseph, obviously always so happy to have you and the partnership with April Air and everything you guys do in the industry. And I think that it was really exciting. I don't know how many of you got a chance to see April Air at the International Builders Show, but you've got a great new energy and heat recovery ventilator system coming online as well, which hopefully you'll talk about today.
Yeah, we've got some new products coming on, and what you guys just teased there at the beginning, I would encourage anyone. You can't get enough education on these new codes and programs. They're driving everything, and they're going to have a big impact on ventilation. Ventilation's just one part of them, but it's certainly one of the product lines that's going to be impacted depending on where you are and what your local code is doing. And that's, of course, if you're beholding yourself just to the code. We'll certainly talk about how you can go above and beyond code, which I think is what a lot of members of the EBA community do, right? We're kind of paving the way here, but staying up to date on those programs, how to take best advantage of them to provide the best homes for your customer, as well as some of the financial incentives that come along with them, I'm sure will be covered. So that's it's all very important. I'm glad to hear you guys are putting that on. So I'm going to touch very lightly on those things today, just as they relate to ventilation. So maybe for anybody listening, if you have deeper questions, maybe think about attending that training. Sounds like that'll be pretty in-depth.
And as always, you put your questions in the Q&A or the chat. I'll be monitoring the questions and serving them up to Joseph throughout the presentation. And then you can always listen to this. We will upload the slides and upload this session to eba.org, to our new learning management or updated learning management system, and as well as the Better Homes, Better Future podcast. So Joseph, go ahead and take us away.
All right. As Aaron said, today's going to be whole home ventilation for today's build. So we're going to talk about your various different options, including an ERV for ventilation that's keeping up to date with the most current codes and programs, as well as just what the right thing to do for your homes and your homeowners is, right? Some of this is code driven, but there's a reason behind it. Just real quickly, a little bit about April Air, established in 1954. We do have a complete whole home IAQ product portfolio, so I'm going to kind of focus mostly on ventilation today with a little bit of touching on air filtration, but we also have a long line, a full portfolio of humidification, dehumidification, radon, UV light radon, something that could also become more important to this community as you see, Indoor Air Plus and some of those new programs potentially starting to embrace some of that. So keep in mind that IAQ is generally not just one product. It's not just ventilation or just filtration. It's really having all of those things. And we're very proud to deliver that whole portfolio. We're always trying to drive new product innovation at our technology center here in Wisconsin. And additionally, something else that I think has always been kind of a great, sort of a synergy with EVA is we really do believe in education. We are constantly out with our contractors, helping them understand the best way to install our products. Same with our builders. Invite us to speak to your trades if you're ever having an issue with our product. These products are only as good as they are installed, so it's so important that we keep the trades up to date on new solutions and the best way to install them.
Yeah. And
So,
Joseph, there's a great story there, right? I mean, you guys just came out with that new, is it the Aprilaire 720
yes,
humidification
yeah,
system?
correct. Yeah,
So just a funny story, like, Joseph and I talk personally sometimes too, but I was like, I want this for my house. So I went to my local contractor and like, hey, I want to get the Aprilaire 720. And he's like, we haven't even heard about it from distribution yet. So sometimes being in the high performance community, we're helping pull those great products through the channel a little faster.
for sure. And I think that's probably not more true that's couldn't be more true in the category of ventilation, right? I mean, I really
Right.
think it's high performance home builders that are pushing HVAC contractors to look at this as more of a comfort and health solution as opposed to just something to check a box during code. But that being said, code requirements are a part of it. So I have up here IMC, IRC, IECC. I'm sure you guys have all heard those acronyms. The IECC is, of course, the energy code that's really, for the most part, driving a lot of these new standards, particularly 2021, which has gotten, fairly stringent. So, even if you're doing the quote unquote bare minimum and building to code, it's getting fairly strict as far as what you need to do from an energy standpoint and thus a ventilation standpoint. IRC and IECC both essentially reference the ASHRAE standards, which is 62.2 in residential homes, and we'll get into a little bit more on what that means. But these are going to be two of the things that help you choose ultimately what ventilation solution you need. But why have we gotten here, and why is energy code calling for ventilation? Well, it's all related to that tighter construction. We have a better controlled environment than we've ever had before. We have less leakage, less natural air changes, and that's certainly good for the performance of the heating and cooling equipment as well as the efficiency of it. It provides us better control over the load in the house, but it actually provides us less control really over the IAQ in the house because we have a buildup of things that occur naturally and come in from outside: VOC, dust, bacteria, viruses. These are things we bring into the home, things we create in the home, CO2 as we breathe out. So, as we tighten this home up and make it, something nearing a plastic bag, we need a way to replenish that air that's in there with something that's more healthy. We do need outdoor air. And despite the fact that, and I think people are, very familiar with outdoor pollution, certainly depending on where you live, that's an issue. But it's when you close an area up and don't provide any air exchanges that you can really exacerbate those problems. There's also, of course, innovation standards pushing some new ventilation solutions. LEED, Energy Star. Obviously via ResNet, if you're getting a HERS rating, ventilation is certainly a large part of that HERS, or it's a part of the HERS number. Again, there's a lot of variables there that make up your overall HERS score. But as people try to bring that HERS rating down, bring their score down, they're certainly going to have to reevaluate some of their ventilation solutions as well. And then just healthy home standards in general are, pushing us towards new methods of ventilation. So kind of the hot topic certainly for this year and leading up to this year has been IECC 2021, and it has had a large impact on ventilation codes. It's hit some states with a lot of new home building, particularly in Texas. We've certainly seen it in the parts of the Mid-Atlantic and Northeast as well. It's Illinois, that Chicago area. So we're seeing some areas with some pretty large population taking a pretty big jump as they move to IECC 2021 and having to meet those requirements. So, as I mentioned, if you really want to go deep into these, I would look into the program that EVA's going to put on, but just real high level. The IECC is the International Energy Conservation Code, and that defines the efficiency of the type of equipment that's used to deliver ventilation. And of course, talking just about how they relate to ventilation here. This is one chapter of many in the IECC, but it's telling you how efficient that equipment needs to be. The IRC is what tells you how much mechanical ventilation is required in that home. And if it's a multifamily home, then you would consult the IMC, and it would be 62.1 there. So these are kind of the code books that sort of start to push us towards the ventilation solution that we're going to need. And then we'll talk about some of the other variables that'll help you make your decision. So, some of the updates here under IECC 2021, homes in climate zones 1 and 2 must have a tested air leakage rate not exceeding 5 ACH 50, and zones 3 through 8 must not exceed 5 ACH 50. That's actually a case where they went up a little bit instead of down, which was a little surprising. But they did also add in 7 and 8 that an HRV or an ERV, one of the products we'll cover today, is now required. It's of course been the case in Minnesota for a while, but they're starting to expand that, and we'll touch on a little bit later. But I believe 2024 is going to push that to zone 6. So plan on continuing to see that kind of creep down as they begin to see the benefit of that. The building should be provided with mechanical ventilation. That's of course always been the case. And then having dampers and stuff to make sure that we're not bringing air in when we don't need to. And again, these are all outlined under Section 4 of the IECC. Outside of code, a big thing to take into account when obviously when you're considering any variable related to a high performance home, but certainly ventilation is what is that climate zone that you're building in? What are the conditions of the outdoor air that you're going to be bringing into the home? What is the load on that home during different times of the year? What type of a shoulder season do you have? So we have a lot of climate zones in the United States. We're obviously a very large country, and even within some of these designated areas, there's some microclimates. If you look on there, you'll see some spots where maybe it's blue and then there's a bit of purple mixed in. So knowing your exact climate zone is extremely important as you choose some of the solutions that we'll go through today. And again, those climate zones are for various different reasons. They sometimes shift and change. We've seen as new codes come out, so they do sort of change what is considered in what climate zone. And then again, additionally, just we have a changing climate going on in the world right now, and that's impacting where some of these lines are. So another big thing, of course, why do we have to bring the air in? And that's going to be related to how tight the home is. We mentioned, we're looking at pretty much 3 to 5 ACH under IECC 2021, which is a moderately tight home. 1.5 to 3 is tight, and 0 to 1.5 is very tight. I'm sure we have plenty of people in the EVA community who are building at 1.5 below, so they're building a very tight home. That they understand this, and that's going to be where you get your most energy efficiency, your most control over the load. As we get above that 5, 7, 7 to 10, you're probably looking more at older existing homes, whether that's because they just weren't built as tight as newer homes, or because over the years the elements have maybe reduced the effectiveness of windows and caulking and sealing, and some of that they're gonna be a looser home. But even on this looser side, and something we do like to talk about is new homes become existing homes. If you're on the new construction side or not, but also on the retrofit side, or you're a contractor on the service side, these things all apply to existing homes too. Everything that's healthy for a new home is healthy for an existing home. So a blower door test on an existing home, you might find out that home's tighter than you thought it was. Or maybe you have some type of an energy retrofit. You get new windows, you get new siding, a new roof is put on there, the attic to spray foam. Those are all things that are changing this envelope and potentially changing the air changes per hour of that house, which might make you want to consider ventilation for the first time, or maybe a different solution if there's already one in there. Here's our IECC 2021 adoption. This is as of July 2023, and I believe this is pretty current. You can see in some areas there's certain locales that have done it, and others full states have done it. As I said, Illinois has come online along with Chicago, some areas in the Mid-Atlantic. Louisiana, which has been an interesting one because they made a pretty big jump when they
Yeah.
went to IECC
That was
2021 from where they were.
yeah, weren't they at 2006 and went to 2021?
Yeah, I mean they had to grow up fast when it came to energy code. So
Yeah.
that's
By
of course
by the way, to help for the builders down in Louisiana, if anybody's on the call, we are looking at EBA training down in Louisiana because I think it was such a big jump for the industry.
Yeah, and you know, not only was it a big jump in energy code, but they also have a challenging climate zone. I mean, that is a
Yeah.
it's a very moist climate. It's an area where when you're building these tighter homes, when you're building to IECC 2021, you're probably going to face problems that you haven't faced before, and problems that you know, builders in maybe more temperate parts of the country wouldn't face. So it'd be great to get a training down there for sure. Not going to go through this except really just to show the disparity across the country in energy codes. We're kind of all over the place. You know, Aaron, as you mentioned, they were I think they were below 2009. Now they're up there at 18. They're a high performing one in Louisiana, but really states are all over the place. Some have no statewide code. And this map is actually more of a efficiency gauge. So it's not even necessarily the exact code that's adopted. So point just being, you really need to know your state and local code to fully understand what you're going to be responsible for. Of course, that goes without saying, but it's very hard to make claims for any equipment and say this is the solution across the U.S. because there's just so much variation. Unlike, you know, in Canada, they're pretty rigid in their requirements, and they're pretty much the same across provinces and municipalities, whereas we just don't have that here.
Right.
So, you know, what changed on a ventilation side? Well, HRVs and ERVs, well, this isn't new. They gained some benefit under IECC 2021. And what you want to look at when you're choosing a solution here, kind of the main thing that's outlined in the IECC is what is that CFM per watt? And for an ERV or an HRV, that's 1.2 CFM per watt. And that's essentially telling you how efficiently it's delivering air. So how much power is it using to deliver fresh air? And this is a case where higher is better. So 2 is better than 1.2, 4 is better than 1. Or better than 2, but you want to be at least anything below 1.2 would technically not rate under IECC 2021. Another change on just the supply side, if you're not talking about an ERV, but just a standard supply ventilator fan in a box, that went up to 3.8 CFM per watt. I believe that was 2.8 before that. So we're starting to see the efficiencies of these come up. And something else that's really moved the needle this year, and probably what has created the biggest change for us, and I think all ventilation manufacturers, is that 1.2 CFM per watt on the air handler means that dampered solutions have kind of been pushed out, and you're seeing a lot more folks go to a power ventilator. I mean, that's in areas where 2021 is, we are seeing the shift almost entirely to a minimum of a power ventilator, if not an ERV. So just a kind of passive or dampered solution, it is not meeting that requirement anymore. So definitely a big change there. And again, we've seen that ourselves. We've heard it from our customers. We've heard it from our competitors that definitely seeing a move towards that power supply ventilator. And then the IRC requirements, as I said, are going to tell you airflow. What we're showing here is continuous airflow. A little bit later on, I'll get into how you might deliver that intermittently, depending on which product you choose. But basically, it gives you a square footage and a number of bedrooms. Then it tells you how much air to deliver. So between the IECC and the IRC, you've got a pretty good starting point for what you're going to want to choose for a ventilation solution, at least how much air it's going to need to deliver and how efficiently it's going to need to do it. And I do have a note here. Typically, ERVs are operated continuously, but as with all of our products, there is an ability to do that intermittently if you want, but you do have to adjust the airflow, and we'll talk a little bit more about that, the benefits to that, as well as the benefits to continuous operation. As I mentioned, you know, I think this is a pretty far out for most people, and of course, things aren't adopted the year that they come out. But you know, at some of the various events in last year, we did hear what was coming down the pike for 2024, and you will see ACH drop again in certain areas down to 2.5 in climate zone 6 through 8. As I mentioned, recovery ventilation is also going to expand to climate zone 6. So you know, codes are not going to get less stringent. And as I say, you're seeing that ERV sneak into more climate zones. You're seeing that air changes per hour continue to go down. Although again, these still aren't super aggressive. I think for the folks that we have on the call here today, high performance builders are probably beyond well beyond 5 ACH at this point, but they're pushing, you know, again, even production builders to much higher standards than they've been at before.
Well, I think there's an interesting interplay there too, Joseph, because if you want to aspire to be under a 3 ACH 50, oftentimes you need to have an ERV or HRV product in there to deliver fresh air to that home because you're getting it too tight to not have that type of product, right?
Right. I mean, you've certainly put yourself in a position where there's going to be noticeable health, comfort, and even preservation issues in the home, particularly if you're in a high moisture area and that moisture
Mhm.
has nowhere to go because of that tight envelope. That's going to create problems real quick. So, yeah, if you're trying to get that super tight envelope, you need to just plan on ventilation being a part of it. And I know sometimes that's frustrating, right? You're building this super tight home, and then we're telling you to punch a 6-inch hole in it and suck outdoor air in. But unfortunately, we do need to breathe. So how we do that, how efficiently we're able to do it, is kind of what we're gonna talk about today. And that's why ERVs are so important, because they do the best job of balancing that need to preserve our energy efficiency with the need to deliver healthy air. But if you do have a looser home, or if you were living in a home 20, 30 years ago before mechanical ventilation was a popular thing, you still had ventilation, you had natural ventilation, as we talked about at the top of the webinar here today. It's a great day in Wisconsin to just open your window. To be perfectly honest, it's about 64, 65 degrees. The humidity's kind of low. It's a sunny day. You get all the fresh air you want in your house and not feel guilty about it. But that is not the case all the time. And generally, natural ventilation is, of course, uncontrolled. We can't control what the conditions are outside. They're very nice today, but they were very unfavorable just a few days ago. And 2 weeks ago, we had like 6 inches of snow on the ground. So we don't have that many days where just opening a window is going to be our best solution for ventilation. And that's especially true, as you get into some of the southern climates where you get very extreme moisture and temperatures in the summer months. Certainly safety concerns too. I mean, most of us don't want to just leave our windows open all the time, certainly not first-story windows. So being able to bring fresh air in a more controlled manner is essential. And the other part of natural ventilation is just when the parts of your home aren't sealing properly. So maybe you're not opening your windows, but you have such leaky windows or leaky door frames, or improperly insulated attic, that you're getting that natural ventilation. Good to get that fresh air in there, not the way that you want to do it though. Next is exhaust and negative pressure ventilation, is accepted under code in many different instances. And when I talk about exhaust negative pressure here, I don't want anyone to think that there is nothing wrong with bath fans and range hoods. They play an unbelievably important role in ventilation, for spot ventilation, for doing away with a sudden increase in a kitchen or in a moisture in a bathroom, certainly smoke, cooking contaminants in a kitchen. Absolutely an essential part of managing ventilation in a home. But as the whole house solution, we're going to talk about why it's really best to go supply or balanced and have a little bit more control on that air coming in. Because when you use exhaust ventilation, you actually put the house under negative pressure. And while you're exhausting from a known point, you're kind of pulling in from all over the place.
Right.
And if you think about it, that turns the house into a filter, right? It's pulling that
Right.
air. Who knows what it's pulling it through, particularly in an older house. Who knows what the conditions of the materials that are in there. So if you can design it so that you're pulling that air in from a known source, that's going to be a better way to do it. Now, it does follow the path of least resistance, so it's probably going to find a leaky window or something like that. But again, best to go to supply or positive pressure ventilation. And in this situation, we're pulling in from a known source. In the example here, we're also sending it to a central air handler to disperse it through the home. But regardless, you're bringing it in through a known source, and then it's going to find its way out through the path of least resistance, which might be knocking open a bath fan flop damper, range hood flop damper, or some other leaky point in the house. But you've put the home under positive pressure. You're protecting against if there is combustion equipment in the home. I think we're going to see less of that, obviously, with electrification. But if there was combustible water heaters or stoves in the home, you can prevent a backdraft situation, which can be very dangerous. So don't plan on going below supply ventilation for your whole home solution, would kind of be the takeaway here. But we now know the best solution of any is going to be a balanced solution which is where air is forced into the home at the same rate that air is forced out of the home. And I'll put a little bit of an asterisk with that, it's actually within plus or minus 10 CFM. Again, I would favor to the, most of the time I would favor to that being on the supply, have a little bit more air going, coming into the house than you do going out of the house to keep yourself in a positive pressure situation. When it comes to balanced ventilation, technically you could have balanced ventilation without recovery. If you just had two fans that were bringing air in and sending it out at about the same rate. You're not going to have a whole lot of benefit to that over probably just supply. If you're doing balanced, it would really make the most sense to have some type of recovery, either heat or energy recovery, because what that's doing is that's preserving some of the conditions in the home. It's keeping the load down on the system from the air that you're bringing in, preserving some of the conditioning that we've done in regards to temperature and moisture. ERVs can be ducted to the HVAC system, but not always. Sometimes they can also pull air out of bathrooms. They can be on a dedicated duct system. We won't get super specific on how to duct today. If you look through our materials, obviously we get more into that, and that's going to be different depending on how your homes are designed. But again, that's something else to take into account, and that's why I said early on that these solutions are really, they depend a lot on the installing contractor and your relationship with him and how you ultimately want this house to perform. There's different ways to install these solutions. ERVs have the lowest operating cost, but they do have the highest installed cost. Again, that is sometimes probably why we don't see them more often, why they're maybe not standardized on as much as you would think. Certainly for the performance of the home and energy efficiency, there's no question they're the best solution, but they do add a little bit of cost. And if you're in a state like Louisiana where you had almost no requirement for ventilation, to the most expensive ventilation product you could put in is a pretty long, that's a lot to swallow as you're trying to keep costs down on a home. So probably why we haven't seen, why we're still seeing them grow, but of course people are getting over that price point as they realize that it really is just, it's the right thing to do. And there is an energy payback there as you preserve some of the conditions of the home as you ventilate. So that being said, how do you choose the right product? Based on what's out there, putting together code, what's available, etc. I'm going to cover obviously Aprilaire products today, but of course these categories would apply to really any brand. There's kind of a passive system, which is a dampered solution where you usually just have a 6-inch damper and it's going to use the central fan of the furnace or the air conditioner to pull that air in. So it's going to do a fan call anytime it needs to ventilate. That's generally going to be an intermittent as well. So it's not going to be pulling in continuously, but it's going to ventilate periodically based on how much airflow is needed. But it's going to use the central fan to do that. So it's not super efficient. That fan's not really designed for efficiency on the ventilation side. You're running that fan more often than you would probably want to. However, it is a commonly used solution, and certainly in areas where code permits it, it's common. We do try to offset some of the negatives of using that system with our 8120X control because it provides some lockouts for temperature and humidity, so that you're not bringing in extremely raw air all the time. So that can be hooked up in various different ways to lock out based on the conditions outside, bank that time in code mode. Lockout for temperature will bank that time. You will still meet ASHRAE 62.2, but you'll be able to lock out for temperature and then make up during cooler parts of the day. Of course, within the requirements of it, it does ultimately need to ventilate about 1 hour of every 4, but provides you a little bit more leeway, a little bit more control over the load. Next step up is a fan-powered system. Similar controls to the dampered system. The biggest change is going to be that you have a much more efficient fan in that box, and it's operating independently of the central fan. So that's why these fan-powered systems are much more efficient, and that's why you're seeing them take off under IECC 2021, because they're a more efficient way to deliver that fresh air. And of course, depending on the product, with our 8144 NC, you can dial in that airflow a little bit as well. There's some more filtration options. Our 8145 has an available high MERV filter that could go in it. So you get a little bit more control over your ventilated air when you move to a fan-powered system versus a passive system. Next, energy recovery ventilator, as I mentioned, really kind of the best all-in-one solution for balancing energy efficiency with fresh air ventilation. Of course, have that core in there that's going to maintain those conditions. You do have a filter on there as well. Um, Ours could be used with our 8120X control. So if you did still want to use some of those lockouts and ventilate intermittently, that's an option. But you can also run continuously. You just run at a much lower speed. And the reason that's more common with an ERV is because you're tempering that air a little bit. It's not as much of a shock to the homeowner to have a constant flow of air coming in. Whereas if you're just bringing kind of raw air in through a dampened solution, they would probably notice how aggressive some of that air is as it's coming into the house. And then another solution that we have is a ventilating dehumidifier. Um, on the energy side of things, they certainly don't earn a ton of points. But if you're in a truly um, very high humid climate, then you absolutely might want to consider this because an ERV is not a dehumidifier. It doesn't lower absolute humidity. It's kind of restricted to the delta between the outdoor and the indoor air. This product is actually going to remove humidity from the air as it delivers it from the house, or it can even, outside of a ventilation call, dehumidify the house. So if the house is having significant humidity problems, both from a ventilation call and without a ventilation call, there's an opportunity to mitigate that more than you could with just a ventilation solution. So again, that's an option in some of the more humid aggressive climates. So really the takeaway here is there's a broad range of solutions that ultimately will work for ventilation, but we're kind of really going to focus for the sake of energy efficiency on the 8145 and the energy recovery ventilator. And then if your moisture is your issue, we'll look at the ventilating dehumidification system. But I would wager to say that anybody part of the EVA community is probably not going to be doing a passive system. You're going to be looking for, at the bare minimum, a fan powered system and probably that energy recovery ventilator. If you don't know what an ERV is, it's a fresh air ventilation unit that brings that outdoor air in. And when it's correctly installed and balanced, it's exhausting the same amount of air as it's bringing in. It's passing that through a core with some very interesting thermodynamic principles that allow that warmer, more humid air to transfer its energy to the cold or drier air in the winter, opposite in the summer, which provides a kind of preconditioning to that air. Again, as I mentioned, it tempers it so you might not notice it quite as much as it's coming into the house. It's also reducing the load that the system has to make up for. Obviously, when you're bringing outdoor air in, you're going to negatively impact the conditions in the home. So the less moisture we can add, the less cold or hot air we can add, depending on the time of year, or dry air, depending on the time of year, the better. Allow our HVAC system a little bit easier time managing that load while still delivering healthy air. A little bit closer look under the cover of the V22. Again, this is an ERV, not an HRV. It does have a core in it that's a 5-year core. It should be cleaned annually. It could be replaced after 5 years. Although in all honesty, if you keep it clean, it's probably going to last much longer than that. 6-inch duct collars. Big change from our previous unit, which we'd had for some time, is that it has 2 independent fans so that you can set the fan speed for each one differently. Our older model and some other ones that are still on the market have a single motor with 2 squirrel cages, and then you use what's called a balancing damper. Well, let me rephrase. Hopefully, the installing contractor uses what's called a balancing damper to make sure that those airflows are balanced. Oftentimes they're installed without that. And if that's the case, you really don't have any assurance that you're truly balanced, because you've got, depending on how much static is in the rest of the system, you could be supplying far more or far less than you're exhausting. With these fans, we're able to dial in the fan speed specifically, and then by taking a pressure reading, we can see how much airflow we're actually delivering and making sure that both of those are equal. It's going to operate continuously with the control that's on board, with the option to do intermittent control with lockouts via our 8120X control. Again, just another look at how these work. With an ERV, you will see 2 penetrations to the outdoors. This is something else that sometimes comes up as an obstacle. Particularly, we've heard about it in the mid-Atlantic, maybe on some like 2/2s or some very narrow homes where you really you're supposed to be 10 feet apart on an intake and an exhaust, it can sometimes be kind of hard to find that real estate. If it is, there's something called a concentric kit that might help with that. If it's allowed in your area, where basically the stream is split and it's coming out of one a single penetration to the outside. But you'll have two on the outside, one bringing in fresh air, one exhausting stale air, and then on the inside you'll have an inlet, which is pulling out that exhaust air to send it outside. And then you also have a fresh air to the home, a dedicated supply to bring that air in. That could be dedicated. It could go to the return. It could go to the supply. Again, we won't get in on the specifics of how you would want to install that. It's going to vary from application to application, but do know that you've got an exhaust point and a supply point on an ERV. Our particular ERV comes with a bracketed system that allows it to go either 24 inches or 16 on center, depending on which way you turn the bracket. The unit can be installed in any orientation, and it will still operate correctly. ERVs, unlike HRVs, don't have a drain because they don't have to expel that moisture. So any orientation will work just fine. The unit will work fine whether it's up and down or sideways. And that bracket unit just makes it real easy to, you hang that bracket and then you just hang the ERV on there and tighten it down. It's a little bit easier than having to hold up the entire unit and screw it to a stud or a wall. Can also be installed on floor joists using that same bracket. Obviously, that's common in attic insulations, particularly in Texas and some of those areas where we're starting to see more installs. Putting that on the floor is also an acceptable way to install it. Compliance, as I mentioned, it's well beyond that 1.2 CFM per watt. We were 1.45 at our highest fan speed, and at our maximum SRE, we're over 3. So a very efficient unit. Based on delivered airflow, you could potentially reach a house up to 6,000 square feet. Again, we can look at that a little bit closer when we get into the ASHRAE chart again, but up to potentially 6,000 square feet. Again, keeping in mind, these products alone don't do this, but depending on what else you're doing, they're among the tools that could help you get some of these 45L incentives, help you build to the new Energy Star requirements, net zero requirements. And I think most importantly of all, outside of code and different incentives, is the fact that this is just how you provide a healthy and comfortable home to the people that are going to move in that house, and how you do it while keeping some energy efficiency in mind. I mean, ventilation systems dilute that trapped indoor air that, as I mentioned, is just full of contaminants that we bring in, contaminants that we create in the home, and the ability to constantly be refreshing that air in the home is something that most homeowners are certainly going to notice. They're particularly going to notice it if they've lived in an existing home that was maybe looser, and now they've purchased a new very tight home and it doesn't have proper ventilation. Those are the people that are going to be most likely to think, okay, well, I moved into this more efficient, newer, better home, and all of a sudden it smells all the time. I'm damp. I'm uncomfortable, and that's why it's important that we maintain that health and comfort that come with delivering fresh air into the home. A little bit on our other solution, the Model 8145. As I said, your best solution certainly for energy efficiency is going to be that ERV that we just discussed. But in some climate zones, and certainly depending on the price point or how far you want to go on the energy efficiency side, a supply ventilator is also certainly a solution. It's going to be much more efficient than just using that central fan. Our 8145 is our solution for that. That's our powered ventilator. It can be controlled by one of our thermostats or by an 8120X control that comes with it, or one that's mounted separately. Again, you get the advantages there of temperature and RH lockouts. Depending on how it's wired, you can have it piggyback off of different comfort calls, heating, air conditioning, and you can have it engage that fan to better distribute the air throughout the home. Again, there's various different reasons why you may or may not do those things, but they're all options within our control algorithm to make sure that you're delivering the proper amount of air. A little bit, even if the folks on this call aren't going to be the people ultimately commissioning this equipment, I think it's important to know what's required and why. And this is some of the stuff that raters or inspectors are looking for when they come in and test ventilation in the home is what is our actual measured delivered CFM, right? Because for every home that could be different depending on how much ductwork you have on the delivery side or the inlet side of the unit. That's going to change how much air is ultimately coming in. So while the unit might be rated to deliver 250, if you've got 390-degree bends in that ductwork before it ultimately hits the living space, you're not actually going to be delivering that. So you need to make sure that these are being measured when they're set up so that the actual value of air being delivered is known. It can be dialed in. And I think that's the most important thing we see when we hear about a ventilation problem in any home, regardless of what the product was. It probably wasn't properly commissioned and measured when it was installed. And you're just kind of going by, hey, I'm going to put a random number in here and think that works. What is nice about our unit is once you know how much airflow you're delivering, it will automatically do the 62.2 calculation for the minutes per hour just by putting in the square footage and the number of bedrooms. And then again, the model E100 and 8190FF. If you're familiar with our dehumidifier, it is essentially our dehumidifier with this fresh air plenum on the front of it. I kind of think it looks like the thing that's on the back of the DeLorean in Back to the Future, but so that's what you've got there is that 6-inch on top. That's where we're bringing the fresh air in, and the 10-inch underneath that is just extending what would be the usual 10-inch inlet on our dehumidifier. So there's a single damper, a single actuator in there that rotates that damper, and when you're bringing in fresh air, it closes off that 10-inch, and when you're recirculating indoor air to dehumidify, it closes off that 6-inch. So, and the reason we have this larger plenum instead of just having both of them right on the front of the unit is to maximize the amount of ventilation airflow that we're able to get out of this. And we can get up to 150 CFM with this unit because of that plenum design that we have on there. So allow you to hit a larger home and have better airflow on that ventilated air. Like the 8120X control, there's some different ways you can install this to utilize the air conditioning system as well. All of that is in the install and operating manuals. But definitely, again, a great tool if you're battling high humidity in Florida, Louisiana, areas like that, where you just, even with an ERV, you're just going to have so much moisture coming into that home. And even if you still choose to use an ERV as the ventilation solution, don't discount having a dehumidifier in that home somewhere. Managing excess moisture is just so important, particularly in a tight home. So if you're not doing it on the ventilation side, at least do it with a dehumidifier somewhere in the home so that we're able to keep that home below that 60% RH, even a little bit lower than that, prevent mold growth, prevent mildew, the health issues that come with that, not to mention the damage that happens to your home. And we all know mold is a 4-letter word in the building industry, and dehumidification is among one of the best ways to avoid that if the rest of your HVAC equipment is not able to keep up with it. So again, it's just a look. Our standard dehumidifier with this collar coming onto it is how that works. Real quick, let's say there's a call for ventilation without a call for AC. It's going to use the dehumidifier that's in the system to dehumidify that air. If a call is made while there's AC, we'll piggyback off of that and ventilate so that we're conditioning that air before it's delivered, and we don't use the onboard one because the air conditioner is running. If indoor RH is above the set point, but there is not a call for fresh air, then that damper will close and will circulate that air and operate just like a standard dehumidifier would, dehumidifying that air that's in the house to bring that RH down. So product selection, I've kind of covered this, but again, after code, next place to go is your climate map. We're going to say from an April air product standpoint, if you're in zones 1 or 2, strongly recommend you consider that ventilating dehumidifier operated intermittently. That's the way the control on there works. After that, you're going to have options of ERV or supply ventilation. When you get to climate zone 6 or 7, you might also potentially consider an HRV there instead of an ERV. And you can run those continuous, or if it's even with an ERV, if conditions are extremely strong, you might still want to consider intermittent control to lock out some of those times. If it's really, really harsh. I mean, maybe you don't want to ventilate when it's -10 degrees outside, or you want to wait till a little bit warmer part of the day. You have the option to do some of that. In addition to the climate map, again, there are certain states where balance is going to be your only option anyway. We sort of see a lot of that in the West, around the Portland area, in Washington State, Minnesota. So you have areas that have already said, hey, ERV is the best solution. Let's just require everybody do that. Obviously, all of Canada does that. Probably going to take us a little bit longer in the states to get there. We kind of seem to be taking baby steps towards more efficient ventilation, but we're getting there. And again, one of the reasons why it's hard to just assign a single product is we do have so many variations in climate zones here that there's not necessarily a one size fits all. I'm going to go through this really quick, but just to kind of cover how that 62.2 works. If you got a 1,500 square foot home with 3 bedrooms, you'd want to deliver a constant flow of about 60 CFM. Now, when I talked about intermittent, the way that works is if you deliver more CFM, so if you have a unit that can deliver 120 or 150, you could start to bring that time down, and now you're not bringing air in continuously. You're bringing in a larger amount of air for a smaller amount of time. The benefit to that mode versus continuous is we can control when we're bringing it in. We can do it during more temperate parts of the day, when there's less humidity, less heat, less cold. So a little bit more control over how often we're bringing that air in. And additionally, there won't be quite as noticeable of a comfort impact on that person and the inhabitants of the home if they're not feeling that come in continuously all the time. So again, both are acceptable, whether it's continuous or intermittent. Just want to make clear that you have that option of delivering either way, depending on which control you use. A few other considerations, and then I'll be wrapped up here if we have any questions. But I think a big one is the outdoor air fresher than my indoor air? And that's another question, that when we're talking about mechanical ventilation, it doesn't probably get brought up as much because we're mostly worried about, hey, this home is so tight, we just got to get outdoor air in there. But it's not always better. The outdoor air can at times be polluted. As I mentioned, we have those lockouts because it could be extremely high or low in temperature or extremely high in RH. So managing to some of those things is important. Our ventilation solutions also do have an event-based button, as well as a way to turn down how much they're ventilating or turn them off completely. One of our most common calls during the last round of wildfires was, how can I shut this unit down until these wildfires are over? I just don't feel comfortable bringing air into my house right now. And that's a legitimate concern. Usually indoor air is more polluted than outdoor air, but there are certainly times, depending on what's going on outside, that is not the case. That's where having an air quality monitor in your house could help a lot. Generally, you should see ventilation bringing those negative things down. If you're seeing them come up and the AQI, the air quality index, is bad, maybe you want to consider changing your ventilation strategy for the day. What are we doing in the house that makes it unhealthy? Again, as I mentioned earlier, range hoods are very important. If you're not turning on a range hood when you're cooking, you need to. That's going to be a great way to right there at the source spot ventilation, get out the smoke that you're creating from cooking. Even if you're using an electric stove, there's going to be some particles sent up into the air when you're cooking. So it's extremely important to try to get those out of the home before they disperse into the rest of the house. So take advantage of your spot ventilation solutions. Do not light scented candles. They are absolutely terrible for indoor air quality. While they might make it smell nice in there, they're doing it by releasing all types of stuff in the air that you don't want. So avoid those things. Certain types of diffusers, really anything that's adding odor to the home is probably doing it via some sort of VOC or something that you ultimately wouldn't want in there. So, instead of maybe covering up bad odors with candles and that type of stuff, get fresh air in the home via a ventilator. That's going to be a much healthier way to do it. Be aware of the cleaning products you're using. That's a really easy way to add VOCs. Again, it's a case where you feel like you're doing something positive. You're cleaning your surfaces, but if you've got a tight home and you don't have ventilation, you could be adding quite a bit of contaminants to the home.
Yeah,
when you're
that's
cleaning.
that's an interesting one, Joseph, that I don't think we always think about, but I kind of learned that from the LEED rating system, that in commercial buildings, they require like green cleaning products or to isolate your cleaning products into a room with a fan in that room. And I think we think, oh, I'm cleaning, it's going to be better, but there's a lot of VOCs that get put in the air when you're cleaning, right?
Yeah, I mean, take bleach for example. I mean, bleach is we use it in cleaning, but it's certainly not a healthy product, right? So
Yeah.
we need to be aware of that. And
Right.
I think another great thing we've seen again among the high performance builders is making sure the other products in the home also don't off gas these types of particles. So low
Sure.
VOC paints, low VOC carpets. Even if
Yeah.
everything else you did in the home was healthy, if any of your building materials are filled with these materials, that's going to off gas into the house for a very long
That's
time,
right.
especially when they first move in. That's what
Yeah, and I
happens.
think that's that interplay you see with like the Indoor Air Plus program where you want no added formaldehyde or carb 2 compliant products or Green Guard Children in Schools certification on some of your materials. So, these all kind of stack and they all kind of tie together, but it's really getting to, I think, what you're talking about, which is it's so paramount to have healthier homes for the occupants at the end of the day. Because what is the number, Joseph? Don't we spend 91% of our time indoors, something like that?
Yeah, and post COVID, we're spending a lot of that in our own homes. So,
Right.
some commercial buildings probably had better indoor air quality than our homes
Sure
did, and
they
we
do.
don't even get the advantage of that anymore. So,
Yeah. Yeah.
um,
Good
keep
point.
keep keep your space healthy. Um, So to that end, two of the best solutions that you can have in a home, if humidity is not an issue, bring in that fresh air ventilation and have a high efficient filtration source, some type of at least a MERV 11 filter on your central system. This is just going to help you make sure you've got that fresh air. It's going to take away those VOCs, CO2, the gaseous things that are in the house, and then a filter is going to trap particulate matter, pollen, viruses, bacteria, depending on their size, etc. So when we look at all the things that go into a house, really a good ventilation system and better than your 1-inch furnace filter are pretty small investments to make for the long-term health of the
Hmm.
person who's going to live in that home. I mean, you know, uh, you, you would think it wouldn't be hard for a homeowner to spend a couple $100 on these products if they're spending 50 on a hardwood floor, right? These are going to preserve your health. These are going to make you feel better. They're going to protect your family. So yeah, that's the other way. What if you do have trouble selling some of these solutions, just remember that they're health and comfort related and they're a relatively small investment when you're talking about protecting your health.
Right.
So that's my spiel. I know that was kind of long. I'll answer any
No,
questions if there are some, but
absolutely fantastic. And I think it's incredible to see some of the investments that your team continues to make around the field of radon, around ERV and updating that product, and around the dehumidification product and updating that. So hats off to you. I think we had an interesting question come in from Joe Nagan, and I'm going to go through that. But what can we all do to, great technology, it's continuing to get better and better, but how do we bring our HVAC contractors, kind of their qualifications and their training, how they install this, how they commission it, up to improved qualification levels so that the builder and the homeowner are actually getting this level of surety from the product once it's installed? And
right.
maybe the answer is partially, I mean, I know all the work your team is doing around training radon installers, right? But what do you see in the kind of ERV, HRV, dehumidification, ventilation spaces? Like, how do we get?
Uh, I think a lot of it is certainly working with the vendor of your product to make sure that they have a direct line of contact to that trade. You know,
Yeah,
particularly when it comes to IAQ, and I think this might be the biggest obstacle. HVAC guys are doing the majority of their business and making the majority of their money off that core equipment, that
sure.
heater, that air conditioner. You can't really hold them responsible for maybe having IAQ as a second. I think it's important to let them know that this is extremely important to the performance of your home, and these are
Mhm.
things that you expect to operate correctly. And understood, it's a new solution. Let them know that the manufacturer is there to come in, help them, do training, show them the best way to install it. And again, just adapt as needed. Something else, what when we come out with new equipment at April Air, often the change was initiated by the HVAC trade saying we would like it to be easier to commission, easier to install.
Mhm.
So we're trying to take away the pain points that, you know, that are there sometimes with this IAQ equipment. So, I'm not sure I have a great answer there. I think it's just that you need to be very forward that IAQ is important to you. If you're not, it's going to be an easy thing for them to strike from a quote or put in without a whole lot of time because, hey, you've still got heating and you've still got air conditioning. Is anybody really going to notice that ventilator or that air filter? You probably need to be the champion of that for your potential home buyer with
Mhm.
the trade. And of course, involve us. I mean, again, we have a long history with the HVAC trade. They're extremely skilled at this. They know the best way to put these products in and the best application for them if they're familiar with it. So I'd like to see
Yeah.
more of all three of us working together,
Yeah.
to deliver these solutions.
Agreed. And do you have a kind of certified April Air installer program, or is there something we can look at on your website to
We
find?
do. We do.
Okay.
On aprilairpartners.com, you can go to
Yep.
find a pro, and that will be a list of people who, through various different measures, have achieved a level of better installation. They've completed a certain number of trainings on the products. They understand how to install them, how to size them, how to recommend them. So that's kind of our high performance IAQ contractors. There would be our Find a Pro on the April Air Partner website.
Okay. No, that's great advice. Another question that came in, the new ERV, is there an option for a in-wall installed product for multifamily?
Um, the current one, no. Uh, there's products to hopefully soon meet that need. I do know what they're referring to, of course. But this particular product, I mean, it's smaller. There are multifamily situations it could fit in, but if you really needed a small product and one that was a little bit more aesthetic into the wall, this one's probably not the one for that. But
Okay, but in the pipeline,
yeah,
watch
yes.
for it in the future. Okay, because yeah, that's sometimes for multifamily a nice option to
Right. And
have.
particularly we're seeing, and this is kind of true everywhere, but I mean, we don't give a whole lot of real estate to the mechanical closet, and you give even less to it in a multifamily situation.
Right.
So bringing an ERV into a multifamily closet is challenging, but as is always the case, sometimes um, those things that fall under the IMC are actually a little bit more progressive than single family building. So.
Right. Great point. Um, well, I'll give a second for any other questions. Definitely put them in the chat or the Q&A. Um, talk to me more about give us a little bit on the radon product too, maybe here at the end, and how, I mean, I liked how you guys were thinking about it, that we used to think like, oh, we're in Minnesota, Wisconsin, we have to have radon. It's terrible here, but depending where you go in the country, it can be uh, pretty terrible everywhere. And it's almost better to look at sometimes having a passive system in and then being able to activate it down the road.
Yeah, for sure. I mean, I think, the EPA map, I wouldn't call it dated. I would just call it not the full story, right? And by the
Right.
EPA map, I'm referring to,
It's
it's
more
something that it's
it's
kind
more
of a
generalized instead
right.
of
Yeah,
specific to your location.
it's a guideline. And the one thing
Yeah.
you'll hear a lot in radon is, one house, it could be super high, and the next house, there could be almost none. Instead of
Mhm.
erring on the side of, well, maybe my house is none, assume
Yeah.
your house is the bad one on the block. And at the very least, at least measure. And I think, when we look at what Indoor Air Plus is asking, I think just making sure a house isn't on a pocket of radon when it's constructed, regardless of the region, is a
Mhm.
good idea. And if you put that passive system in, yeah, that's really cheap to do,
Right.
in a new home when you're putting that under the slab and you're just venting it out. Much less expensive than it would be to do after the fact. And I think the other kind of stereotype of radon, Aaron, is that it's something that's done during a real estate transaction.
Right.
When somebody new is buying that home, they'll check that box on the inspection.
Right.
Why do you want to be the one that lives in the house with a radon
Yeah.
problem for 10 years and then fix it when the next person moves in? So,
Right.
and what April Air's tried to do is engage the HVAC contractor in that more, whereas traditionally that may have been there were kind of specific groups that did radon stuff. It was maybe a little bit more on the plumbing side, but what could be a bigger part of healthy air than mitigating cancer-causing agents like radon? So getting the
Absolutely.
HVAC trade involved in that, essential.
Right. And then, Joseph, did you say that you were looking at having some spot ventilation product available from Maple Air as well?
Something we're looking into as well. Even if it's not our specific offering, I just wanted to let folks know that you hear some bad things about exhaust ventilation, but you have to consider how they're being used. Range hoods, bath fans are good. You should make sure that homeowners understand why those solutions are there, when to use them, etc. So, yeah, again, constantly keeping that house breathing, sending the bad out, bringing the good in. We want to do that with all of the tools available to you in the house.
Great. Well, Joseph, we sure appreciate April Air's commitment to building science and to healthier homes for homeowners around the world. And we're so happy to have had you here with us today.
Hey, Aaron, thank you for having us. Again, we very much value our partnership with EBA. We like to see what you guys are doing. I know I attended this show, of course, for years, and attendees at EBA are certainly some of the most aggressive and smartest in the building industry. So we're honored to be sharing a little bit about our products with them today.
Great. Thanks, Joseph. Thanks,
Thank you.
everyone.